String is a commonly used data type because data science often involves studying text data. In this video, we will review just a few of the many useful string operations in Pandas. For those of you who worked through the Python basics a few weeks ago, you'll recognize that many of these methods are quite similar to the methods from Python strings. By the end of this video, you should be able to describe what operations the string methods can perform, navigate your way to find the right string method for you, and perform basic string operations in Pandas. One of the most important string operations is split. It helps with separating data into pieces around a delimiter character. For example, the city column in the df data frame here is split around the underscore character, returning an object with arrays of all the pieces for each row in the city column. To be clear, the city field now contains an array of strings rather than just a string. For the split function itself, notice that city underscore 0 has been turned into two strings, city and 0. The same has been applied for each string in the city column. The function contains provides a simple way to check if a string has a given character in it. We already used this in our live video coding sessions before, but let's look at this example when we check if any of the values in the city column contains 2 as a character. We see that only index 2 has it. So the result is a Boolean series with only one true value for that index 2. Using the replace operation, we can replace a substring with another one. For example, we are replacing the underscore character with 2 hashtags here. The extract function will return the first match for a regular expression it finds. The top example here is a regular expression to extract words in a string, and the bottom example is how we can extract the strings. In general, extract can be a quick way to get new features and values. For example, you can use it to build a numeric feature out of text data, like in the lower example. In summary, string operations can be very handy in data cleaning. Please use the link provided here to get started on exploring more string operations to make yourself familiar with the rest of them. Okay, now let's see a few string functions in actions. As a reminder, the movies table has the title and genres columns. Both of these columns, however, have composite information. Let's use some string operations to separate out the values here. When I said composite operation, I meant Toy Story has also the year, and genres has more than one genre, all stringed together by those pipe characters. So we will start by the split function to convert each value in the genres into a separate column for each movie. We need to select the genres column from the movies, and on each row, or to that whole data frame column, we will use the split function, str.split, with pipe as the separator. Normally, the split function will return a series of lists. By providing expand through option here that we have given to the split operation, we make sure the output is not just a series of lists, but it's an actual data frame. We see it as a data frame. So let me run this and display the first 10 rows in that new data frame. Okay? You can also add a new column to detect each genre, if it's comedy or not. This will be handy when creating new features in your machine learning course later in the MicroMasters. What we are doing here is now we split all the genres into a separate data frame. So when we look at that, this would be normally adventure, pipe, animation, pipe, children. So we have this data frame. Probably one of the rows has 9 genres in it, which is why we have 9 columns here. We will now add another one that says true or false if the movie genres is comedy, and it will call that column is comedy. So let's run that and select the first 10. Now we see that last column is called is comedy. It's added to the same movie genres data frame, and it has true or false values. Lastly, let's add yet another column called year. And we'll separate out the year from that title that we've seen in the original data frame. So what we'll do is we'll extract out, for example, 1995 as a separate column instead of together with the movie title. We will use the extract operation here. We are selecting the title from the movies, and we'll provide it a regular expression similar to what we had in our stream editor discussion in the Unix part earlier in this class. This regular expression here says extract any value in between the parentheses in that string value that comes out of that movie's title column for that row. And if you remember, expand true will make it a data frame. So we're adding to the movies data frame, not to this new one that we made, movie genres one, but the original movies data frame. And we'll call that new column year. So what we extracted as the year using this extract function and regular expression will be copied as a new column at the end of movies. If we run this now, let's go first run our extract operation. Then let's get the bottom of it. We'll see that year is a new column here. And it just gives us the year that was mentioned at the end of the title in a new column. This could be pretty useful when we are doing quick grouping over that year. All the movies in, for example, year 2007, we'll need to group that by with that year column. Initially, we couldn't do this because it's a part of that title. So there are many other string operations, of course, and your ability to work with text data will often depend on your knowledge of these functions. We can't list all of them or give you examples on all of them, unfortunately, but please spend some time going through these operations at this link that we provide here. We'll also, of course, have some more examples in the upcoming notebooks.